Okay, so let's have a look at the 2023 Higher Level Maths Leaving Cert Paper 2, question 9. Ava is looking at different tilings, that is different ways of covering a region with shapes. So first question then, first she looks at two different tilings, one using identical squares and the other using identical regular hexagons. And it just says here that a regular hexagon can be split into 6 congruent equilateral triangles. Now a square tile and a hexagonal tile each have an area of 140 centimeters. Work out the length of the side of the square tile correct to 1 decimal place. So that's fairly straightforward. If you have a tile that's square and each side is x, the area is equal to x times x. And that's just going to be equal to 140 centimeters squared. So that just gives you x then is the square root of 140. And it says give your answer to correct to 1 decimal place. So that's just going to be 11.8 centimeters. Okay, so let's have a look at part 2 of this part. The hexagonal tile has sides of length x, where x is an element of OR. Work out the value of x correct to 1 decimal place. So they've given us a little diagram here showing us how the hexagon can be broken up into 6 congruent triangles. And each of these triangles is equilateral, so the angle here is going to be 60, 60, and 60. So a couple of ways of doing this. Let's see, the first way I'm going to do it is just using half AB sine C. So in other words, if you take this triangle here, with 60 degrees here, and you've got x here and x here. All you've got to do is find the area of one of these, multiply it by 6, and all of that should equal to 140 centimeters squared. So let's do that first. So you've got 6 multiplied by half AB, so that's x times x, which is x squared, times sine 60. So that all should equal 140. So let's just work our way through that. You can see here you've got half of 6, which is 3, x squared sine 60. So x squared there is just going to be equal to 140 divided by 3 times sine 60 degrees. So that gives us an x squared. Well, I'll just square root. I'll just go directly to x. All you've got to do is square root this here. So what you should get is 7.3 centimeters, and that's to 1 decimal place. So there is another way of doing this. I mean, you can have a look at, let me just write this down first. So you can take one of these triangles. This is 60 degrees here, this is x, and x here. So what you could do is find the area again of one of these triangles a different way, half the base times the height, work it that way as well. So you'd need to find this distance here first. So out as far as here is going to be half x. So this is going to be half x, or x over 2, just here, just from here to here. So you can do, let's see, you would do h squared plus half x squared is equal to x squared. So just get h on its own. So that would give us, let's see, h squared plus a quarter x squared is equal to x squared. That gives me h squared is equal to 1x squared minus a quarter x squared is going to be 3/4 x squared. And that'll finally then just give me h is the square root of 3 over 2x. So now I can just find the area of this triangle here. So it's going to be 6 times, so we're doing 6 of these. So it's going to be half the base. The base is x times the perpendicular height we've just worked out. That's root 3 over 2 times x. And again, that's equal to 140. So you've got the same kind of thing here. You've got a half of 6, which is 3. So we've got, let's see, we've got 3 times x is x squared, and then you've got 3, actually I'll do it this way, 3 root 3 over 2 x squared is equal to 140. You can multiply across by 2 and divide by 3 root 3. That'll give you x squared is equal to 53.886 and so on. So we just get the square root then of 53.886. And that also gives you 7.32 centimeters to 1 decimal place. So just 2 different ways of doing it. There are probably others as well. They're just 2 ways. Let's have a look at the next one then. Next, Ava looks at more complicated tilings. The tiling below is made up of 2 shapes, an arrowhead ABED and a quadrilateral EBCD. So you've got your arrowhead here, and then you've got a quadrilateral here. The point E lies on the line AC, and both shapes are symmetrical about AC. So you can draw a line across here, and this shape here will be exactly the same as this shape here. So let's see, AD is 8 centimeters, so this is 8 centimeters up along here. AE is 6, so this is 6 centimeters. ED is 4, so ED is 4 centimeters here, this distance here. As shown in the diagram, alpha is the angle DAE, so this is alpha here. Show that alpha is cos inverse 7 over 8. Okay, so we have a triangle here with 3 sides, and that should indicate that we need to use the cosine rule. Also the fact here that you've got cos down here as well might give you a clue. So we're going to start with the side opposite the angle we're talking about within the formula. So we're going to start with 4, so it's going to be 4 squared is equal to 6 squared plus 8 squared minus twice 6 times 8 cos alpha. So that's the cosine rule. So here we have 16 for 4, 16. 6 6 is 36 plus 64 minus 96 cos alpha. So what you need to do is subtract 36, subtract 64. That'll give you a negative answer, and then divide by minus 96, and you do indeed get 7 over 8. So that just means then that alpha is going to be equal to cos inverse 7 over 8, and that's it. Okay, so let's look at part 2. In the diagram, the angle ADC is equal to ABC is equal to 90. So ADC and ABC are equal to 90. So in other words, these two angles here are 90 degrees. So that's a right angle triangle. This is a right angle triangle here. So let's have a look and see where we're going with this. Use this and part B2 to work out the total area of the quadrilateral ABCD corrected 2 decimal places. So I've just copied down the diagram from the question earlier, and we're just going to have a look at triangle ADC. So we're going to find that area first, and then we're just going to double it. So let's have a look at that. So we have a right angle triangle. It looks like this. A here, D here, and C here. This is 8. Alpha now, remember, is cos inverse 7 over 8. That's the angle. So you could work that out on your calculator and write in the angle to so many decimal places, but I'm just going to leave it at cos inverse 7 over 8. So the way I'm going to do this, remember this is a right angle triangle here, so I want to find the area of a right angle triangle. And that's usually easy enough to do, because if you have the base, all you got to do is work out this here. This is going to be the perpendicular height, or this is the base, and this is the height, whichever way you want to do it. But either way, I'm going to work out DC first. So the way I'm going to do that is look at tan of this angle here. So the tan of this angle, which is cos inverse 7 over 8, or if you've worked it out to so many decimal places, you can just write that in. So that's just going to be equal to the opposite over the adjacent. So this is the opposite here. So that's going to be the distance CD, which we want to work out, over the adjacent, which is 8. So if you just multiply across by 8 now, that'll give you CD. So when you do that, you get 4.4262666 and so on. So that's this distance here, CD. So once I have that, I can just do half the base times the height and multiply it by 2. So the area of our quadrilateral ABCD is just going to be twice half the base. Well, we'll take the base as, let's say, 8, and the perpendicular height as 4.4262666. Now, when you work that out, you get 35 to 2 decimal places, 41. And that's centimeters squared. Okay, there are other ways of doing that, but that's just the way that came into my mind anyway initially. So let's have a look at C then. Okay, so we're getting into more complicated shapes here. Ava also looks at a tiling of the inside of a unit circle. So this is a unit circle here, and the equation is x squared plus y squared is equal to 1. That just means the distance, the radius, the distance from here out to here is going to be 1 unit. So the distance from here to Q is 1 unit, the distance from here to P is 1 unit, and so on. The tiling she looks at is shown on the left below. The diagram on the right below, not to scale, shows the circle C and another circle S. The points P and Q are on both circles. The part of S that lies inside C is an edge to a number of the tiles. Ava wants to find the equation of the circle S. The angle QOP, let me just write that in there, the angle QOP, so this angle here, so this angle down here is 45 degrees. So we want to show that the point Q has coordinates minus 1 over root 2 plus 1 over root 2. Okay, so on page 13 of your tables, then you'll see a unit circle, and you'll know that any point on a unit circle, so any point on a unit circle has coordinates cos theta, sine theta. So we know that this angle here is 135 degrees, just subtract 45 from 180. So if we find the cos of 135 degrees and the sine of 135 degrees, that'll give us the coordinates of Q. So the cos of 135 is the same as the cos of the reference angle, which is 45 degrees. The cos of the reference angle, 45 degrees, is 1 over root 2, and the sine of 135, the sine of 45 degrees, is also 1 over root 2. Now we're in the second quadrant. That means cos is negative in the second quadrant, so this is minus 1 over root 2, and the sine is positive in the second quadrant, so this is going to be plus root 2 here. So that's really it. So let's move on to the next question. The point P lies on the x-axis. The center of the circle S lies on the tangent to C at the point P and on the tangent to C at the point Q. Find the center and radius of the circle. Give your answer in third form. Okay, so I've just copied in the diagram again here. So let's have a look at where these tangents are. The center of the circle is going to be, let's say, here, maybe down a bit further, maybe here. And there are two tangents that go through that center. So the two tangents are going to look something like this. And another one up along here like this. I'm going to miss the center there. So this line here is going to be vertical because it's a tangent at the x-axis here, at a point on the x-axis. So the equation of a vertical line, this particular line here, remember this distance out as far as here is 1 unit. It's actually minus 1. The coordinates of P are minus 1, 0. So the equation of this vertical line is going to be x is equal to minus 1. That's the equation of this line here. So that means the center here must have coordinates with an x as -1. So we just got to find the y. Now the way I'm going to do this is I'm going to look at finding the equation of this line here, this tangent here. So remember, the equation of a tangent is y minus y1 is equal to m multiplied by x minus x1. So we need a point. Well, we have a point. It's minus 1 over root 2, 1 over root 2. So there's our x1, y1 anyway. But we also need the slope. So the way I'm going to do that is I'm just going to have a look at this line here, this radius. We know that this angle here is 45 degrees. Therefore, the slope of this line here must be actually -1. So the slope of that line there is -1. That just means that the slope of our line here must be +1. If you think of it as -1 over 1, turn that upside down, change the sign, you get +1. So the slope here is going to be m is equal to 1. So we have the slope and we have a point, so that's fine. We can just work away here. We got y minus y1, which is 1 over root 2, is equal to our slope, which is 1, x minus minus, which is plus 1 over root 2. So let's just multiply across by root 2 here. So you got root 2y minus 1 is equal to root 2x plus 1. So just to rearrange that, our equation of our line then is 0 is equal to root 2x minus root 2y plus 2. So this is one equation, if you like. Our other equation of our second line, our vertical line, is just x is equal to -1. That's our second equation. So we're just doing simultaneous equations with these, if you like. We're just going to substitute -1 in here for x. That'll give us our y. So at x is equal to -1, equation 1 then will give us 0 is equal to the square root of 2 times -1, so that's minus root 2, minus root 2y plus 2. So let's just isolate y here, so bring over the 2 and the root 2. So we're going to have root 2 minus 2 is equal to minus root 2y. Y is going to be equal to, you can just put this into your calculator. You'll divide root 2 minus 2 by minus root 2. And when you do that, you get a y value of -1 plus root 2. So there's our y value. So that just means that our center, the center, is going to be equal to x is -1 and y is -1 plus root 2. Now, if our center is -1, so we could measure -1, we go up along here -1 plus root 2. This distance here will give us the radius. So in other words, the y value here is simply the radius. So our radius is -1 plus root 2. And that's it for this question.